So once again, very warm welcome to all the subscribers of Futuromics Bioinformatics Made Easy YouTube channel. So hi guys, welcome all of you. So as you all know that in the last couple of tutorials which has been uploaded by Futuromics channel, it's providing you an overview regarding how you can proceed for the computer-aided drug designing approach. And whenever if you are planning to move in that specific CAD approach, that is computer-aided drug designing, so you have to proceed with the computational approach to process your drug discovery, right? So in that context, we have discussed certain tutorials which is uploaded by YouTube channel of Futuromics, where you all of you get a good guidance regarding how you can proceed for the step-by-step data retrieval of drugs, and even moving with respect to the specific approach where you can plan with respect to the drug designing, right? So in the previous thing of the drug discovery, by performing the molecular docking using bioinformatics approach, we all of you saw that using AutoDock Vina, we have to perform several commands, right? So using certain commands, you have to proceed for the docking, right? So, and that is what we have done for the batch docking, for the multiple ligands or the drug, right? But today, in this particular video, we all are going to discuss about a web app or as a web-based resource which is available called as a SwissDock, right? So SwissDock is now available with the new upgraded version, which is integrated with AutoDock Vina. Yes, AutoDock Vina is directly integrated with this web app. And previously, I think we have even discussed about the SwissDock with earlier version, what you can all of you find over here, right? The old version of SwissDock is available. But now we are having the SwissDock with respect to the AutoDock Vina as a plugins, right? So we are going to see how to take the maximum benefits of this web application in the form of importing the files and then getting the docking results accordingly, right? So all of you can see here that he just mentioned that SwissDock, Swiss drug designing, you can even explore the homepage, what we are right now. You can even go for the about documentation and FAQs, where you will get to know more information about what is the new updations has been added in the SwissDock application, right? And how you can take the maximum benefit of this application. Whereas you will even get the tutorial, right? And some command analysis for that, right? But here we are going to see that how to use this web application for drug designing by again using AutoDock Vina as a program, right? So here you all of you can see that if you just scroll down, so you will get the two things available in this homepage. The first is docking with the attracting cavity. Okay, so means is what where you have the cavities, it will just perform the docking, right? Or else you can even go for docking with AutoDock Vina. So we are going to see the both the approaches over here, how we can do the first docking with this approach, which is get default selected. As you all can see that if you just select this approach, then the certain steps are included in below, right? And then we are going to see in the second half of the tutorial, like how we can perform the docking with AutoDock Vina, right? So moving ahead now, a quick discussion. As you all can see that if I just click on this, so it will switch with this one again. You can find the steps will be included, okay? But first we will go with this approach. And you can see that if you want to try with the example, so they have even provided you the PDB ID. That is what we required over here. And the drug name with respect to the drug as a target, right? So if you just scroll down, guys, so you can see that the first thing what we have to do over here is that to submit the ligand, right? You can either paste the smiles over here, or else you can upload the MOL2 file format accordingly. Even the advanced options are even there where you can directly call the name of the drug and then it will get retrieved from the databases such as CHEBI and PDB accordingly. For a while, what we are going to do, we are going to use the example so that you all of you will understand that how to utilize this example for the reference context, right? So it has been asked that to take the ligand first. So I'm just click on that And all of you can see that once I just click on the ligand, or as the ligand file in the form of this file format has been pasted over here, this particular first step will get uh, proceed with respect to the prepare the ligand, right? So that is an important step. You have to simply click on prepare ligand. So prepare ligand is nothing but where it will help you to make your drug in the form of the docking step, right? So in this step, you can see that it will take some couple of seconds, right, to prepare your ligand. So this is exactly what we used to do in the AutoDock Vina, right? So we used to prepare the ligand, right? So in this same way, here in this online application, you will get the steps to prepare the ligand. There is one more thing, guys. You all of you can observe that you can even use the sketcher. It's nothing but like a Marvin view or the Marvin sketch. So you can even sketch your ligand over here, right? So once the preparation of the ligand is done, the next thing you can scroll down, you can see that it will ask you to submit a target, right? You all of you can see that the checkbox is done, means the ligand is get prepared, right? So once that step is done, guys, so the second step is nothing but submit a target. So here the default target is selected with the PDB ID, but you all of you can change as per your interest, right? So here you can even give one more thing is nothing but the chains. So if you're interested, guys, so to go and perform the docking in the specific chain, right? So you can even do that. So here the default chain A has been selected accordingly. Got it? And then choose the heteroatoms. If you want to include any of that, you can select, or else you can directly upload the file of PDB if you have, right? So I hope that you all of you get the point of the second step to select a target protein, right? So if you are just prepared to the target, it will same do with respect to the ligand. So now the thing is to observe from here is that here there is no need to prepare any kind of protein or the ligand in the by converting into the PDBQT, right? You can directly use the standard file formats, maybe the SMILE or else the STF or else the MOL format, or else you can even sketch for the ligand, right? For the PDB of the protein, you have to submit directly. And then the very good thing what you can do is that rather than just deleting the chain, what we used to do in the AutoDock Vina, here we can just select the specific chain what we require to perform the docking. I hope you all of you are getting the point, right? So moving ahead, now you can see that the protein preparation is also done. Now the most important step, what you all of you can see here, is nothing but the X, Y, Z coordinates, right? So how to get this X, Y, Z coordinates? Again, this tutorial is have been uploaded earlier with this channel, right? With where you will get like active site prediction tool. So you can upload your PDB and then you will get the active site, right? So this is the X, Y, and Z coordinates are provided with the box, right? And once that is done, you all if you can see here, the full screen, this is exactly the only chain A has been selected, right? And then you all of you can see that the box with the cavity has created, right? Once that is done, you all if you can see that the atom is get selected over here, and help to control options are even provided. If you just scroll down, you can see that many good things which is included, like select the molecule interaction. Okay, if I just select, so here, if I just select this one, right? Yeah, all of you can see now, right? So this is the specific region is get selected. So you can just click on cation action, interaction pi, okay, hydrophobic static stacking action, right? You all of you can see here. I will even select this one. So you all of you can see that. Show the protein surface. If you just do that, guys, so you all of you can see the protein surfaces get included on your screen, right? So I think this is really a good virtual representation. You can even reset accordingly. Okay, so this is exactly what the surface protein is get selected, right? So I think this is a really good way to get the information, and then the select the parameters. So it's nothing but the random initial condition will get generated over here. So you can check the parameters accordingly by just clicking on here, right? So how those parameters is get checked, you can just check it out in the question mark icon, right? So it will again give you very detailed information, like before a docking, we need to check your parameters, which is checked in the grid content. Okay, so it's nothing but it will check the box, what you have given is correct. Okay, the sampling exhaustic, okay, cavity, and then it will even show you the and cavity region, right? So that is the one thing which is get provided, and then it again it's get check mark, right? So now the important step is that you can provide your email ID also here, but again it's optional, guys. Why the email IDs has been given, like if the work will be in the queue, right? So you will get the results on your mail rather than just waiting for getting the results, right? So simply start docking. If you do this, so now it will again give you important information, like what kind of parameters we have given over here, right? So the parameters will give you which way, whatever we have given. Okay, then please let the page open in the new browser to redirect the results, and will get page automatically get calculated, right? Two things will be done, so you have to patiently wait for the things to get the results on your screen. So that's why providing the mail ID is important. You all of you can see, guys, here. So the calculation current time is showing to all of you, right? So once it's done, you will get the results accordingly. Got it? So this is the one way of getting the results. Once the results is get appear, then we will just make a quick interpretations for the same. Got it? Meanwhile, we will have a look on the second approach. So basically in the second approach, you all of you can see that yeah. So in the second approach, we are going to see like how to go for docking with AutoDock Vina, right? So if you just click on docking with AutoDock Vina, so you can proceed with the same thing, like select the drug, right? So, so drug can be selected from here, and then prepare a ligand. Once that is done, then scroll for the next option. It's nothing but the protein PDB, right? And then prepare the target. Very simple, right? So this is a way where the third thing is done is nothing but the XYZ coordinates with respect to the cavity regions is that get provided, right? Then check for the parameters. Once the parameters are been checked, guys, so you all of you can see that you can again begin for the docking, right? So now the thing is that what is the difference between these two, right? Going for docking with AutoDock Vina and then with the cavity one. Okay. So in the results part, we will just making a quick interpretation so that you all of you will get the difference between these two options and how you can proceed for the same, right? And then I will just begin for the docking. So you all of you can see that both the pages are working. The first page is where we have given the cavity information and it's done for the 15%, right? The second one, which we saw that we have gone for the AutoDock Vina, right? And it's again, it's in the 7% of running, right? It went to 12%. So we will have to wait for some couple of minutes so that you will just move for the interpretations of the results with both the approaches, right? So I hope that you all of you get the overview and you get the difference, right? So we have done two steps, right? The first steps we have moved for the cavity. The second way of approach is that we have moved for AutoDock Vina as a docking, right? But here, if you all of you have observed very much clearly, guys, you can see that in this particular method, we have given only one ligand, right? So here is a less chances that you can give multiple ligands for docking. Okay, so that is a small drawback, what you can say, or else the thing what you can't do from here is that you cannot perform multiple drugs to give for docking, right? You have to give for single ligand with the single protein. Got it? So that is the one thing what you will get from the web-based docking application. So the so why it is, guys, like why they have not provided multiple ligand? The answer is simple because on the web, to carry out the huge simulations will take a huge time, right? So that's why it's provided only the one option to give you the results for the one ligand, right? So you all of you can see guys now, first the results is get appear for the docking with AutoDock Vina, right? And the second thing we will just check it out that it's working, right? So we will just quickly make the interpretations of this SwissDock with AutoDock Vina. You can see that the query what we have given over here, right? So the query, you all of you can see that it's provided over here, got it? With the SwissDock one. And then here you will find the ligands what we have given, right? With the parameters. So we are getting the parameters available over here. Okay. And with respect to that, we are able to see the reference. Okay, the type of reference with the papers where the relevant kind of research is done. So 2024, like 2024 is a recent research was done with this kind of small molecule with the docking study. And one more paper you can see in the 2021, right? So it is again, it's a strong reference what you can get for your further results and interpretation. And this is our ligand, what we have given as an input, right? And moving ahead, so these are the basic things which we have provided as an input. The second thing is are nothing but the results, right? So in the results, you all of you can see that to how to understand your results, it's a 3D panel, display your structure of target protein. It follows the table containing the ligand pose, okay, calculated by the AutoDock Vina. All of you can see here, right? So it's taking AutoDock Vina, and that is true because we have done the search based on the AutoDock Vina, right? Huh. Then you can click on the line of the table to display the corresponding ligand poses with 3D panel. Okay, so where it is, if you just scroll down, so you all of you can have a view, guys. So this is exactly what the results will get appear over here, right? So this results is showing you the model 1 to 7 and you're getting the calculated affinity with minus 11.82. That is the highest docking score what you get, right? So the 7 models are nothing but the 7 different poses what you get, all of you, right? So I hope that you got the point. So this is how what we get the docking results. So in the kilocalorie per mole, right? So this is for the AutoDock Vina. So minus 11.87 is the highest docking score what we are getting. So now the thing what we can do from here is that just scroll up, right? Select your first target. Once you do that, you all of you can see that the drug has been selected over here. Have a look. Okay. So this is where you all of you can find the drug. Got it. And whatever the dotted lines over here is nothing but the interaction, right? And this is for the chain A, right? So I think that is really very good way of results which get appear on your screen. If you just scroll down, guys, so you can just make the information, right? Hydrophobic one, static interactions accordingly, right? So to get to know which are the residues over here, so those informations you can just click on show surface protein. Now just have a view, guys, all of you. We'll just reset this, right? And here is nothing but now we will select the ligand, right? And then we will just get the pocket, right? So if you can see, guys, like how beautiful the pocket is generated over here, right? So this is a one way of interpreting your results. And you can even select like a multiple ligand as a poses also, like I have selected this one. the second one, right? Or the third one accordingly. So it will show you the regions in that way. And if you just moving the cursors, guys, you can see this amino acids is reflecting. Clear? Okay. So, and then this results, whatever you can see over here, you can even download this, right? You can zip this, you can download this zip file. Once it get downloaded, you all of you can just have a look. I'm going to show you the screen, right? Where in the downloads, the files are there, right? So PDB ligand.pdbqt, right? And Vina.doc results are there. So if you just double click on that, so the text file will get open, and basically in the text file, all of you will get the information about the model, right? Over here. Clear? So that is the one thing. The next thing what you will get is the the next thing you all of you can see here is the docking results, right? So this is how you can get the results with this SwissDock with using AutoDock Vina. I hope guys you got the overview, right? So one more thing I just want to show you, right? It's very simple, right? All of you, that directly you can just take the specific target protein of your interest, and then you all of you can just move for the further interpretations part. Got it? Now we are going to just have a look with the next option what we have provided. We are going to just open that, right? Okay. And then we are going to interpret our results accordingly to find out the results accordingly. So I hope that you all of you get like a quick analysis of the right. So now I'm going to show you like if you want to open this the file, right, where you get the zip of that. So once you just unzip this guy, so you will get this kind of files in front of you. Okay, so like the PDB which we have provided, then the ligand.pdb qt, then the parameters whatever we have given like x5z coordinates, then the smiles in the mol2 file format, system.pdbqt, and the vina.doc with pdb, and vina.doc pdbqt. So the two files what we required guys to show the interaction. So so this is one system.pdbqt and vina.pdbqt. So system.pdbqt is a protein, and vina.pdbqt, we are going to see that how to open this in the PyMOL. Okay, so I'm going to launch the PyMOL now, and then I'm going to open this both the files where you all of you will have a quick view, right? So now once that is done, so file and then open. So which to open is nothing but in the downloads, we had the zip, right? So the system.pdbqt, I hope you all of you are observing, right? The system.pdbqt is the protein, right? And the next thing what we are going to open, so that we will get the docking interaction, right? Next thing we need the last one, that is Vina doc.pdbqt. If you just open guys, so you will get the right thing, right? Where you have this ligand. This is the ligand where the docking is done. Got it? And then the protein, which we have opened right now, right? So whatever the further interaction, how to get the interacting residue and the further things. So that is what we have already given in the uh, one more tutorials with this futuromics, right? So I will just show you one more time, guys, to have a quick look on the same. So once the docking is done with SwissDock, so first you have to open the drug in the form of vina.doc.pdbqt, right? All of you can see that, right? So next thing we have to open the protein, like the system.pdbqt. And you all of you can see this, right? And it is the same what we are able to get. So how to get this interaction and to perform the protein ligand interaction using PyMOL. So again, that tutorial video has been uploaded. So you all of you can refer the same, right? So now we are going back with the next results to get discuss about SwissDock, right? So this is all about, guys. I hope you all of you get the point. Now SwissDock, it's done, 100% showing. So we will just wait for just a couple of seconds to quickly interpret the results of both the things, right? So you all of you can explore the tutorials of about the things like how to get the interaction of the docking, right, using PyMOL. So that you all of you can explore. And the next thing is that how to find the X, Y, Z coordinates of your protein using active site prediction tool. So that reference tutorial is also available. So both the things you all of you can explore with the reference context if you just face any challenge for the further interpretations of your results, right? So that is the thing. So you all of you can see that it has taken around the 13 minutes, okay, to get doc against only one drug. Are you getting the difference? So that this is the second challenge what you will get if you just go for the docking using online web applications. Whereas this the same thing if you just do with the installation of the software. Okay, and going with the command line, which we have discussed in our previous tutorial, that is EasyDock, right? So EasyDock, I have shown you like using only one command, you all of you can just perform the docking. So I think that is again a very good way where you will get the results within a couple of seconds, right? Whereas here you have to wait for like 17 minutes is mentioned over here, right? The results is running from 17 minutes. Whereas the SwissDock for AutoDock Vina has taken very quick way, right? Compared to that. But there you get like a multiple models is nothing but the poses, right? And that poses with the interaction of your protein, you can show and then get the more interacting residues and informations, amino acids information with using PyMOL, right? The results is get appear, guys. You all of you can see here on the screen. So it's the same, right? But here the something what you are getting is a clusters, right? So what is this clusters we are going to see now? So best members by cluster. So two options are there, right? So right now we got only one cluster. So all of you can see here. So right, so the number of clusters are there. If you just make 20, even though you're share getting only one member of clusters, right? So it's based on the Swiss param scores, right? So it's not based on like a AutoDock Vina. So that's why here you are getting like AC scores with the Swiss param scores, right? And what is the importance of using this scores? So basically that thing, if you want to get to know, guys, then my high recommendation to all of you is that please refer the paper of citations. Okay, go explore the paper so you will get the information like what is the importance of the SwissDock or else Swiss param scores, right? So you all of you can see that the cluster is only one, right? So that's why we are able to see only the one clusters by this. Okay, so yeah, have a look. Fine. So this is a one thing, but basically the one more difference is that here we will get only the clusters, right? Accordingly with the scores. Got it? So the results has been showcased over here. Just have a view, all of you guys here. Like to understand your results, the 3D panel below display the results of the target protein. That is true. It follow the two table containing a ligand poses calculated by the cavities, right? So attracting cavities. So best members. So you will find the best members of each clusters and you can choose the number of clusters to display, right? So by cluster is nothing but it will give you a table containing all members of clusters, what you have been chosen to display. So, and to get the more interactions, you all of you can have a view on the, like if you want to find like interaction, so you can explore the camera, right? Tools, surface binding analysis, and view dock. So where you will find your results in the docking interactions, right? So that is a further steps, guys. So I hope that you all of you followed this kind of a tutorial where we have discussed quickly about how the web-based resource will help you to perform the docking based on providing the PDB files or the default files as to for the docking parameters, right? And then we saw like using the cavity-based docking and using AutoDock Vina. So what is the difference we all of you saw, right? And how to get the particular docking interaction again. Here, you all of you can see that we are not able to get the uh, this thing, what you can say is the scores with the kilocalorie per mole because it's not based on the AutoDock Vina, right? It's based on the Swiss param score. So as I mentioned earlier, like you can explore the citing. Can you see that? If you just go for the citing over here, then it will provide you the research papers. Can you see that? So this paper will give you the information like what is the importance of that Swiss param scores, okay, and AutoDock Vina, how it is integrated. So both the things they have provided in this paper. So my recommendation to explore this and then get to know more about the same. So if anybody is planning like to go ahead and then perform the docking with the command line, so I think we have provided lots of tutorials to all of you guys, the beginners, the researchers who are really willing to go ahead and then get to know and understand the computer-aided drug designing because based on this today's era and the future research is depend on the computer-aided drug designing. So it's really important to all of you guys, like you, all of you have to come up with these skills, right? So where you will get to know like how to perform the docking using multiple docking applications and including the command line and upgrade your skills accordingly, right? So I hope that this tutorial also has helped you a lot, right? So please leave your comment below with your feedback, right? Or any questions if you have with you with your queries. So Future Remix will be really happy to answer those query. And please subscribe the channel if you have not done and kindly hit the like button and share the video accordingly. Thank you guys. So in Future Remix will come with more such kind of tutorials, which will be really help those kind of beginner researchers who are willing to upgrade their skills in the computational way to perform their research and be in the race of research and development. So all the best to all of you guys once again, and thank you once again.